Hi students, this is AJ sir. Let's study 10th standard ICSE Math, chapter 20B and 20F, that is surface area and volume of cone and a combination of solids. Now in a cone, this is the radius of the base, this is the perpendicular height, and this is called the slant height. Volume of the cone is 1/3 pi r square h. If you notice, pi r square h is the volume of a cylinder. So 1/3 of that is the volume of the cone, which means that a cylinder can be divided into 3 parts, each of which can be the volume of a cone. Now the curved surface area or the lateral surface area is the area excluding the base, and the formula for that is pi r L. Now L is the slant height, and we can find it using Pythagoras theorem, that is L square is equal to h square plus r square. The total surface area is the curved surface area plus the area of the base, and the base is a circle, so that's pi r square. We can remove pi r for common for ease in calculation. Now in this exercise there are no cancellations. Let's start with the third sum. The circumference of the base is given, so from that we can find the radius, and also the height is given, 12 meters. We have to find the volume. So from the circumference, which is 2 pi r, find the radius, which comes up to 10.5 meters. Height is also given, and volume formula is this. Substitute the values and get the answer. Notice that for ease of calculation, I wrote this as 21 upon 2, so that 2 can get cancelled here and even here. 7 1s are, 7 3s are, 3 gets cancelled, and then the final answer is this, meter cube. Remember, it's volume. Now the fifth sum. There are 2 right circular cones, x and y. X has 3 times the radius of y, and y has half the volume of x. That means x has double volume as y. Calculate the ratio of their heights. So let's start with the ratio. Now, I just said that the volume of x is double the volume of y. So the ratio of their volumes is 2:1, 2 upon 1. Now volume formula is 1/3 pi r square h upon 1/3 pi r square h. I used capital R and small r to distinguish between the 2 different radii and heights of the 2 cones. 1/3 gets cancelled, pi gets cancelled, and it's mentioned that the radius of x is thrice the radius of y. So instead of capital R, let me substitute it as 3r. The square remains outside the brackets. The ratio of the heights is what we have to find. Now here this becomes 9r squared, and then r squared get cancelled. So what is left is 9, which goes down here. It becomes 2 upon 9. So finally I will say that the ratio of their heights is 2:9. Next, the 7th sum. There are 2 cones, and the CSA of one is twice that of the other. So again, ratio can be found out, 2 upon 1. The slant height of the latter, that is the second cone, is twice that of the former. That is, the first slant height upon second slant height is 1 upon 2. Find the ratio of their radii. So same method here. CSA 1 upon CSA 2 is 2 upon 1 given. So pi RL upon pi RL. Capital L is for the first one, of course. Pi gets cancelled, and it's mentioned that the second slant height is twice the first slant height. So I'm going to write this as 2L. So here L and N gets cancelled, 2 goes up. So the ratio of the radii is 4:1. Don't leave the answer in fraction. Now the ninth question, find what length of canvas 1.5 meters in width is required to make a conical tent. The tent's diameter is given, so we can find the radius. The height is given, so we can find the slant height. Now at first sight it seems obvious that we should purchase the cloth, that is the canvas, whose area is equal to the CSA of the cone. CSA means the curved surface area. Obviously we won't have to count the base of the tent because the base will be the ground. No cloth has to be put there. But one complication is that 10% of the canvas is used in folds and stitching, so it's wasted 10%, which makes sense. Obviously when you are buying a cloth and making it into a tent, we should buy a little extra cloth because some percentage will get wasted. 10% of the canvas. And then they've asked for the cost as well. So let's do it step by step. First of all, radius can be found out, height is given, so the slant height can be found out. So the CSA of the cone is pi RL. Now when you do sums, you should actually write CSA of cone, because in exams all exercises will come together. So how will you distinguish between CSA of cylinder and CSA of cone unless you write it? Now we know that this B exercise is only about cone. So pi's value is not given, so we take it as 22.7, and I'm gonna leave it as it is. Let's not divide yet. Let's wait. Hopefully something might get cut in the future. Now it's mentioned that the area of the canvas that we have to purchase is equal to the CSA plus some extra cloth should be purchased, and they have mentioned it to be 10% of canvas. Now here is where you have to be very careful. Sometimes in the question they don't say 10% of the canvas is used. They might say that the 10% of the curved surface area is used. So in that case the formula will be CSA plus 10% of CSA. These things make a difference. In one of the solved examples, both the cases have been solved. But here it's 10 CSA plus 10% of area of canvas. So now this will go to the LHS, and plus 10% of CSA, 10% of area will become minus. So area of canvas minus 10% of area of canvas is 90% of area of canvas. And CSA value we know is this. 90% means 90 upon 100. 100 goes up, 90 goes down. 0, 0 cut. You can cut it further, but I'll just hold on to that. So this is the area of the canvas which we have to purchase. But when we go to purchase the cloth, the canvas, the width of the cloth is already decided. It's 1.5 meters, and the shopkeeper is asking us the length of the canvas we want to buy. So the area of the canvas is length into breadth, out of which the breadth or the width is already known, 1.5. Only the length is unknown. So 1.5 goes here, and I get the length as this. Again, I'm not solving it further. If you wish, you can get some answer. Now once we decide the length, which could be anything, let's say it could be 250 meters or something, or in decimal. Now the cost of the canvas can be calculated as the length into the rate. Notice that the rate is given as rupees 24 per meter. on meter squared or meter cubed. So that's the biggest hint, that we have to multiply this with the length. So now I multiplied with 24, and now the cutting starts. So this can be cut, this can be cut, this can be cut, this can be cut, and in the end multiply and divide and you will get this answer. But you better multiply and divide on your own in the rougher column. I want to see it. Don't do it directly. I did it directly mentally because I can calculate it mentally, but you don't have that level of expertise, so you do it by hand. Don't copy. Now the 11th sum. The total surface area of the right circular cone whose slant height is given is this. So this is the TSA, this is the slant height. Find the radius and then the volume, and pi's value is given 3.14. Well, TSA is 90 pi and slant height is 13. Total surface area is curved surface area plus the area of the base, which is 90 pi given. Now I'll remove pi r common, and L's value I know is 13. Unfortunately, pi also got cancelled. So the only thing missing is r, unknown variable. Open the brackets, you get a quadratic equation splitting the middle term. You get two factors, negative value can be rejected. So the radius is 5 centimeters, and once you get this, find the height using Pythagoras theorem, and then volume is 1/3 pi r square h. Pi's value is given, by the way, so the answer is 314 centimeter cube. Next, the 13th sum. A vessel is in the form of a cone. It is filled with water to the brim. So the total volume of the cone is nothing but the volume of the water. Its height is given, h, and the diameter of the base is given, which is 25.2. So we can find the radius of that, half of it. So h and r, so I can find the total volume. Next, 6 equal solid cones, small cones, 1, 2, 3, 4, 5, 6, small ones, are dropped in it and completely submerged. So obviously some water will be overflowing, and the water which overflows will be equal to the volume of the 6 cones, and they have mentioned that 1/4 of the total water which was there overflows. So the question is, what is the volume of each small cone which was submerged? Come on, try to figure out this sum on your own. Are you able to get it? First, the radius and height. So find the total volume. After substitution and calculation, I'm getting 5322.24 centimeter cube. If you want to hold on to this, keep it in fraction form, that's fine. Now it is mentioned that 6 times the volume of a small cone which was submerged is equal to 1/4 the volume of the water. No need to mention overflowed, because the water overflowed is 1/4 the volume of the total water, and the volume of the total water is already calculated here. You could have used the fractions out here, and 1/4 and 6 will also come down here, and then you cancel and get the answer as 221.76 centimeter cube. Next, the 14th sum. The volume is given and the area of the base is given, and R, H and L are required. But here L is the length of the canvas. Remember, the breadth is given and canvas is asked. Length. First of all, from the area of the base, which is a circle, we can find the radius, which is 7 meters. And now we can find the volume, which is 1/3 pi r square h. In fact, we can find the height from the volume, because volume is already given. Volume is already given as 1232. Pi's value is 22.7. R's value we know. Only h is missing. Send everything on the RHS and get the value of h, which is 24 meters. Now using h and r, we can find the slant height. Notice how I'm not calculating further. I'm just doing it mentally because I know the Pythagorean triplets are 7, 24 and 25. So you can directly write 5 meters here. If you remember Pythagorean triplets, it's fine. Now in this sum, we can say that the area of the canvas to be purchased is equal to the CSA. Since no mention of any wastage is mentioned, so we'll just directly equate it, and CSA is pi RL, and area of the canvas cloth which we have to purchase is a rectangular sheet, so its length into breadth, whose width or the breadth is already given as 2 meters. So the only thing left to be calculated is the length of the canvas, and no cost is required in this sum. Now let's do exercise 20F. Notice the SE number 29 and 30 are cancelled in the reduced syllabus. And in 20F, all sums are cancelled except 4 sums. So question number 2 and 4 will be for homework. And now we are going to do question number 7 and question 3. Rest all the sums are cancelled, either because they are not in the reduced syllabus or they are a repeated type. The third sum, a circus tent is cylindrical, okay, and the cylinder's height is 4 meters, and above it there is a cone, obviously the roof. The diameter is this, which will be the same for cone and cylinder both. Slant height of the cone is given. Total area of canvas required. So let's draw the diagram first. It looks like this. It has a cylinder, it has a cone, both. Now the radius is this for both. The slant height is 80 meters, this part. Height of the cylinder is 4 meters. Now the total area of the canvas required, the cloth which is required, is the CSA of the cylinder and the CSA of the cone, not the bases. There will be no cloth at the bases. So that's 2 pi RH plus pi RL. Remove pi R common, substitute all the values, and we get the answer as this. Don't multiply it yet, because the canvas which is purchased from the market, the area for that is actually length into breadth, and the breadth or the width is already given. So we can find the length to buy from the shop, and the cost will be this length into the rate. Notice how the rate is per meter, so it will be multiplied by the length, and it will cost 1,45,200 rupees to make the tent. So make sure that your circus is a hit to cover up the cost of the tent and other things. Now the 7th sum. Diagram is already given. Great. They've given all the values, like they've given the height of the cone, they've given the total height of the toy. So if I subtract the height of the cone from it, I can get the height of the cylinder, which will be 60 minus 24, 36 centimeters. The radius of the base of the cone is twice the radius of the base of the cylinder, is equal to 10 centimeters. That means the radius of the cone is 10 centimeters, but the radius of the cylinder is half of that, so it's 5 centimeters. Find the total surface area of the toy. That means if I have to paint this toy, what is the area I have to paint? Number 1, I have to paint the CSA of the cone. Number 2, I have to paint this base of the cone, but which is a ring actually. Number 3, I have to paint the CSA of the cylinder, and number 4, I have to paint the base of the cylinder. So let's write all the data first. For the cone, radius, height and slant height, I'm using capital letters to distinguish it from the values of cylinder. These are for cone, and this is for cylinder. radius and height. I got everything now. Now TSE of the toy is CSE of the cone plus area of the base minus this area of the top of the cylinder plus area of the CSE of the cylinder plus area of the base of the cylinder. Now this area of the base of the cylinder and area of the top of the cylinder are equal, so they will cancel each other. So now the only thing left is CSE of cone, area of base of cone, CSE of cylinder. CSE of cone pi RL, area of base of cone pi R square, capital R, remember that. CSE of cylinder 2 pi RH. Remove pi common and the value is given as 3.14. Substitute all other values and solve and you get this as a final answer.
Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.